Alright, Maclaurin series fans, this is the last part of the numerical analysis assignment. It's pretty straightforward. Here's the part from the assignment, Maclaurin series. The mission of this particular section is to approximate this function, natural log of x, as a Maclaurin series. So that means it's going to be centered about 0. That's the only difference between a Maclaurin and a Taylor series, is we say the Maclaurin series is by default centered about 0. We'll see what that means here in a second. Let's go to the spreadsheet. There's not too much here other than simply use this function and put it into the Maclaurin series sort of calculator. Let's see what that process looks like. Here's the spreadsheet template from the assignment. I have used a separate example here. This is the example I'm using. I'm using not cosine of 2x. That's just going to be cosine of x. I made a little change here. So in any case, this is the Maclaurin series we're going to be using to approximate a trig function. What I've done here, this is a function table in this particular spreadsheet. That's all this is. These are my x values, and these are my function values. Again, I changed this to just regular x. Sorry about the correction. Now, here's the math I used to populate this table. I'm simply taking the cosine of all of these x values, and then what I'm doing is I have a multiple series chart over here. So I'm plotting the actual function cosine of x here, and I'm incrementing at 1/2 steps. I added this little increment argument in because I'm using a different function than what you guys will be using. And I'm simply plotting cosine of x. Now there's also another series. When you plot your Maclaurin series approximation, this chart is already configured to plot what appears in this table. And again, this is very similar to power series. These are the x values here, and these are the f of x values that the table outputs. And just to review, the f of x values come from a series approximation based on these x inputs. And again, hidden columns, this is a very wide table, so I've only abbreviated it here. We go from x is starting at -1, and it ends at 16 in this particular case. Now, I'm going to enter this just as I did with my power series. And I like to use this equation bar at the top instead of the actual cell. So I'm just going to start with my alternating Grandi series here. And remember how we do the n values and x values. So I'm going to use A7, but I have to lock the column on this. That's -1 to the n, multiplied by x, which is going to be B5. And I have to, again, lock the row on this one. And I'm going to raise that, and I had to put this in parentheses. This is going to be 2 times A7. Lock the column. And I've gotten my numerator taken care of with that. Now my denominator, 2n factorial. So to do a factorial, the Excel command is fact, and then you have to have a parenthetical argument. So it's 2 times n. And of course my n is A7, and that will compute the factorial of 2 times n, just in the denominator here. I'm going to make one little revision that's sort of extra credit. I'm just going to put my A7 exponent here in parentheses. I don't think I need to do that, but just to make sure. And you can see how much easier it is to edit up here if you have a complex formula as opposed to working down in the cell. And I get an output for that. I'm just going to scroll down and propagate this across the rows, and then I'm going to propagate this across the columns. And you can see it's already tried to output my 0th term, which is a constant in this case. And that's all there is to doing a Maclaurin series approximation. I've created all of my series in here, and you can see that as I add terms, this series, the orange is indicating the number of terms I'm adding up to get this. So these are my first 2 terms, and as I keep adding terms, it becomes a better and better approximation to cosine of x. And you can see here's the infinity. An infinite number of terms would be equivalent to cosine of x, which is a very crazy thought. And that's sort of how we go about approximating a function with a Maclaurin series. Now, Maclaurin series is centered at 0. That means that the center of this series approximation is here. If we were to move this axis, Maclaurin series should continue to go in both positive and negative directions. This is convergent for all values of x. So that means, you know, I can zoom out to infinity and add as many terms as I want, and this will always work as an approximation for cosine of x. Centered at 0 means the entire series is based on the origin right here. A Taylor series you can center at any location on the x-axis, but a Maclaurin series will always be based right here in the middle. Sorry about that. In any case, this is how you carry on this particular part of the assignment. Good luck.